Good morning, students. Myself, Munsi Roshidul Islam, Assistant Professor, Department of Mechanical Engineering, JIS College of Engineering, Kolyani, Nadia. Now, today we have discussed above the point and above the lesson, that is the numerical problems discussion on virtual work. So, last 2-3 class we have discussed the different types of virtual work principle, different types of virtual work parameter that can be depends on the virtual work done. So that is actually covered in the last 2-3 classes. Now today we have discussed only the application, how the virtual work can apply on a specific problem, just like structure, just like one type of frame, etc. How the virtual work can be obtained, and some problems can also generalized in the today's lesson. Now let us see. First of all, introduction of the before the starting the any type of problem solving, some introduction also be needed. So that is mainly last 2-3 classes we have already discussed, but I just recap the previous lessons. So that means if we can observe that whenever a force act on a body and the body undergoes some displacement, some work is to be done, and that means mathematically, if a force acting on a body and displace it through a distance, so that distance is small s, so the work done F into S, that means P into S is actually the total work done. Now a force is equal to the force and multiplied by the distance through which the body has moved in the direction of the force. But if the body is in equilibrium under the action of the system of force, the work done is zero. So we assume that the body in equilibrium under an infinite small imaginary displacement, which is known as the virtual displacement, and some work will be imagined to be done, and such an imaginary work is called as a virtual work. The concept of the virtual work is very useful in finding out the unknown forces in structures. We do not actually displace the system, we only imagine as to what would happen, so if the system is displaced. Now the principle of virtual work, it states if a system of force acting on a body or a system of bodies be in equilibrium and the system be imagined to undergo a small displacement consistent with the geometrical conditions, then the algebraic sum of the virtual works done by all the forces of the system, that is equal to 0. Now this is the problem example of a principle of virtual work. So if I consider a beam of AB which span 5 meter is carrying a point load of 2 kilonewton at a distance of 2 meter from A, determine the beam reactions by using the principle of virtual work. Now span L is equal to 5 meter, point load is W is equal to 2 kilonewton, and the distance between the point load and support, that also equal to A is equal to 2 meter. Now if we see the figure, RA is equal to reaction at A, RB is equal to reaction at B, and Y is actually the virtual upward displacement of the beam at B. Now from the geometry, now for the geometry, we find that the virtual upward displacement of the beam at B is Y. and the virtual upward displacement of the beam at C, that is 2y by 5. So 2y by 5 is equal to 0.4y as shown in the figure. So total virtual work done by the two reactions, RA and RB. So RA into 0 plus RB into y is equal to plus RBY, plus sign due to the reaction acting upward. Now virtual work done by the point load, that means minus Px is equal to minus 2 into 0.4, that is also equal to the minus 0.8 y. Now minus sign due to the load acting downward. So now from the principle of virtual work, the algebraic sum of the total virtual work done is 0. Therefore RB into y minus 0.8 y is equal to 0. So RB is equal to 0.8 kilonewton and RA is equal to 1.2 kilonewton. Now another problem where the two beams AC and CD of length 9 meter and 10 meter respectively are hinged at C. These are supported on roller at the left and the right ends A and D. A hinge support is provided at B 7 meter from A as shown in the figure. Using the principle of virtual work, determine the force which is transmitted by the hinge C and reaction at support B when a load of 700 Newton act at a point 6 meter from D. Now this is the figure, the example of the principle of virtual work. So AC is equal to the diagram of free body diagram. So now length of the beam AC is equal to 9 meter, length of the beam CD is equal to 10 meter and load at E is equal to 700 Newton. So let RA is equal to reaction at A, RB is equal to reaction at B and RD is equal to reaction at D and Y is equal to virtual upward displacement. So the virtual displacement of B and E is 7y by 9 and 6y by 10, that is equal to 3y by 5 respectively. So total work done by the three reactions RA, RB and RD. So RA into 0 plus RB into 7y by 9 plus RD into 0, that is equal to RB into 7y by 9, and the virtual work done by the load is equal to minus 700 into 3y by 5, that means minus 420 y. Now algebraic sum of the total virtual work done is 0. Therefore RB into 7y by 9 minus 420 y is equal to 0. So RB is equal to 540 Newton. Another problem also be there, the example of principle of virtual work, another problem, that means a weight W of 5 kilonewton is raised by a system of pulley as shown in the figure. By using the method of virtual work, find the force P which can hold the weight of the equilibrium. So in this figure, the two rollers which are connected and one side the two ends are supported with the uppermost point, and in the lower roller faces a load W is connected and which load is acting in downward direction. Now let us see the problem. So solution W is equal to, given solution, that is actually W is equal to 5 kilonewton, P is equal to force which can hold the weight in equilibrium, and Y is actually the virtual upward displacement of the weight. Now from the geometry of the system of pulley, we find that the virtual upward displacement of the weight is z, weight is y. So the virtual downward displacement of the force is 2y. Now virtual work done by the load is equal to wy by 5y plus sign due to upward movement of the load. Now virtual work done by the effort, that is equal to minus p into 2y is equal to minus 2py minus sign due to downward movement of the effort. We know that from the principle of virtual work, the algebraic sum of the virtual work done is 0. So therefore 5y minus 2py is equal to 0. So p is equal to 5y by 2y, that means 2.5 kilonewton. So this is the another type of problem related to virtual work. A weight of 1000 resting over a smooth surface inclined at 30 degree with the horizontal and is supported by an effort capital P, which is resting on a smooth surface and also inclined at 45 degree with the horizontal as shown in the figure. By using the principle of virtual work, calculate the value of effort capital P. So there are two conditions are also be there. One smooth surface, one weight which is hanging at inclined surface, that means the 30 degree with 30 degree angle. And now the next problem, now the next cases is one effort also be angled in right hand side and which makes an angle with the base, that is also the 45 degree. Now the solutions, the weight W is equal to 1000 Newton, inclination of weight surface, that means alpha 1 is equal to 30 degree and inclination of effort surface alpha 2 is equal to 45 degree. Now x is equal to virtual vertical displacement of 1000 Newton weight, x is equal to virtual vertical displacement of 1000 Newton weight, and y is equal to virtual vertical displacement of the effort capital P. Now from the geometry of the system, we find that when the weight 1000 Newton moves downward, the effort P will move upward. So we also find that the displacement through which the 1000 Newton weight will move downwards on the inclined surface and will be equal to the distance through which the load P will move upward on the inclined surface. So now the distance through which the 1000 Newton weight moves the inclined surface with AC. So that means AC is equal to x by sine 30 degree. So x by sine 30 value is 0.5. So total value AC is equal to 2x. Now the distance through which the load P will move on the inclined surface BC. So that means the inclined surface BC with some certain angle 45 degree. Now BC is equal to y by sine 45 degree, that means y by 0.0707, that means 1.414 y. Now equating the equations 1 and 2, we can get 2x is equal to 1.414 y or x is equal to 0.707 y. So virtual work done by the effort capital P is equal to plus P into y. That means the P sign plus sign is indicate the upward movement of the effort, and the virtual work done by the 1000 Newton weight, that means minus 1000 in minus 1000 x is equal to minus 1000 into 7.707 y. That means minus 707 y. Minus sign due to downward movement of the weight. Now, from the principle of virtual work, the algebraic sum of the virtual works done is 0. Therefore, Py minus 707y is equal to 0. So, P is equal to 707 Newton. So, that's the problem solution. So, in the today's class, we have discussed more or less 4 or 5 new problems related to virtual work, and also before calculating the virtual work problem, we have discussed some theoretical part that are included in the problems related with. So thank you for today's class. So the end today now end of the class.